Alright, now the activity series. So we've talked about redox and how one element loses electrons and one element gains electrons. But really, it's not so much about a giving of electrons, it's more about the taking of electrons. So the element that is reduced is gaining electrons because it's strong enough to take the electrons away from another element. So if we pair two elements against each other, if one is higher on what we call the activity series, then it's stronger and able to pull electrons away from an element. And this isn't the same as electronegativity. That's about when they share the electrons and then taking one or sharing them unfairly. This is about literally taking the electrons. So here's an example of an activity series. And the activity series, it can be a much, much longer list than this. This is just one example. And what it shows is elements that increase in the ease of oxidation. That means the elements lower on the list are easy to oxidize. And once again, oxidation is loss. So those are the guys who are easily losing their electrons. So an element will be able to oxidize anything that is below it on the list, because anything below it on the list is weaker than it, so it can take its electrons if it wants. So for example, copper, it can oxidize magnesium, but copper cannot oxidize silver. Silver will oxidize copper. So copper can take electrons from magnesium, it can take them from iron, but it can't take them from silver, platinum, or gold. And this is why we use gold for jewelry, because gold is on the top of the activity series, means it does not oxidize, it does not rust very easily. Have you ever heard people talk about how jewelry turns their skin green? Yeah, it's because their jewelry is not gold. It's because it's copper. Copper turns green when it oxidizes, and so the sweat in your skin actually causes the copper to oxidize, and therefore rust, and look a little bit different. So if it was pure gold, it would not tarnish, it would not rust. So if we match up zinc and copper, here's Cu2 plus and zinc. So what we're seeing here is if Cu goes from Cu2 plus to Cu regular, that means it's gaining 2 electrons. So that means it's being reduced, it's gaining electrons by taking them from zinc. So it takes 2 electrons from zinc, becomes neutral. This will happen because copper is the stronger oxidizer. It's higher on the activity series. However, if we match it up the other way around and try and put zinc 2 plus against copper, zinc is not going to be able to take the electrons from copper because it's too weak. And so this reaction would not happen. So here's an old metal trick. Iron, and we all know that iron rusts, and when iron rusts it turns red and pits and ends up falling apart. So one of the ways that they can prevent iron from rusting is by welding a piece of zinc onto whatever iron object we have. So they do this on fences, boats, all kinds of things like that. Your septic tank usually has one of these. So if you have a piece of iron and then you weld a little strip of zinc in it, let's say you put it down there in the bottom corner. Remember that oxidation is the loss of electrons. So if this piece of iron, this big piece of iron with the zinc on it, let's say the iron loses some of its electrons, that would cause it to rust, so turn into iron oxide. But since iron is stronger than zinc, when iron loses its electrons to whatever's around it, so moisture that's in the air, it will then take the electron back from zinc. And so the zinc will rust or oxidize, but the iron will stay the same. And so then once that piece of zinc that's down here is all used up, you can just replace that piece of zinc. And in the end, your piece of iron will remain unrusted. Alright, let's try one together. So copper nitrate, copper 2 nitrate, is poured over solid zinc. So hey, nitrate, that's one of those substances that is always soluble, so we know it's going to stay soluble. We can just call it a spectator. So Cu2 plus, which is aqueous, reacting with solid zinc. So in order for anything to change, copper is going to need to gain 2 electrons to turn to a solid, and it'd have to take them from zinc. Now if we go to our activity series, we see that copper is higher than zinc, which means it can take electrons from zinc. So if we show zinc giving 2 electrons over to copper, that means this is going to be Cu plus Zn2 plus. Now, if copper is now neutral, what state of matter is that going to be in? Neutral copper would be a solid. And zinc as an ion, that means it's ionized in the solution, so it's going to be aqueous.